Okay, welcome to session 15, part D. So, explain chapter 10. It's all about externalities, and it's questions from the back of the chapter. By the way, those I think are the most important questions. Make sure you understand those. You don't have to worry about the rest. Uh, I want to do one more question, though. Now, this book and this course is the idea is that it's not designed for economics majors, and so the technical aspects are a little bit lighter than the usual course, and it's not endless repetition of demand and supply curves. Now, and the book does that. The textbook does not have as many demand and supply curves as the usual economic textbook. Um, so which I think is good, but I think there's the book may overdo that aspect or underdo the demand and supply curves. There's one classical example that I think the book is missing, and I want to have one more problem to illustrate that concept. Okay, and it's illustrated by this problem. Okay, and this could be a problem on the exam. This is a very important problem. Okay, here's how it goes. Um, Suppose the demand curve for gasoline is represented by the D curve in the above graph. The marginal cost of gasoline is 250 per gallon. Assume this is constant, i.e., the marginal cost graph is horizontal. Okay, so I've done this graph. Here it is. If this was on an exam, I would write the graph for you. Um, so notice, you know what? I didn't label the D curve. That's this. Okay, so here's the demand for gasoline, and then the marginal cost. So let's assume this is the suppliers are gasoline stations, and so the marginal cost of a gallon of gasoline is 250. So this is what it costs a gasoline station to buy it from distributors, say. Um, and let's assume that's constant, okay? So you buy the first 10,000 gallons at your gas station, it's 250 per gallon. You buy 10,001 gallon, it's going to be an extra 250, okay? The marginal costs do not go up as you increase your quantity, okay? We're going to assume that's the case, okay? Assume that this is constant, okay? Now, you should remember the supply curve always equals the marginal cost curve, okay? So, gave the marginal cost curve. It's this flat curve. Okay, since supply curve is the marginal cost curve, this means that the supply curve is flat. That is, it is perfectly elastic. Okay. Question A: what is the market clearing quantity of gasoline? Okay, so you should already know this from our earlier chapters, and it is this. So we look where the supply curve crosses the demand curve. Take the dotted line down from that point, find where it crosses the quantity axis, and it's 100. So let's say this is in millions of gallons. Okay, so that is question A. 100 is the answer. Question B: when autos use gasoline, they release pollutants. Assume that the social cost of pollutants is $1 per gallon. What do I mean by that? So what I mean by that is that if you could poll people, look inside people's heads and say, um, what if you could reduce the pollutants from that extra gallon of gas? How much would you pay for it? Let's take the sum of everyone's answer. Everyone would say, well, that one tiny gallon, that's not very much. You know, the quantity consumed and supplied in the U.S. is 100 million gallons per day, whatever it is. So that 1 gallon isn't very much. Maybe I would say 0.0001 cent for that 1 gallon. That's how much I'd pay to reduce the pollutants from that 1 gallon. But you add this up over all the people in the United States, and let's say you get $1. Okay, and the key is that you could estimate this cost. It would take a little work, and you'd need people to be truthful on surveys, but let's assume we can see inside their heads. But that's what I mean when I say social cost. How much would people be willing to pay to reduce emittance by that much? Okay, so it's dollar per gallon. What is the socially optimal quantity that is bought and sold? Okay, now usually we say that the market clearing price and quantity is efficient. It accounts for all the trades that should be made, all the trades for which someone's value is higher, that's buying is higher than the value of someone selling. So the value of people selling is the supply curve, value of people buying is the demand curve. Whenever the demand curve is above the supply curve, we should see a trade there. We keep on seeing trades until they cross. Okay, see, that's the socially optimal way. Okay, the socially optimal amount. The problem is when you have an externality, the costs are not reflected in the supply curve. These suppliers, these gasoline stations, are not taking account this extra dollar of social costs. But what I'm asking though, what is the socially optimal quantity that is bought and sold? That is, if suppliers took account of the social costs as well as their monetary costs, what would be the market clearing quantity? Well, the answer is if they accounted for these extra costs, they would just add a dollar to their marginal costs. They would say the total cost, the total marginal cost, is my monetary cost, which is $2.50, plus the social cost, a dollar. That gives me $3.50. Okay, so if that were the case, these are the costs. We should make a trade whenever the benefits to someone are higher than the costs. So each of these points represent such cases. But also when we get here, no longer is that the case. At this point, the benefits from an extra gallon of gasoline are lower than the costs. So we'd say that trade should not get made. Okay, what would be the quantity that should get made under this system? The answer is 80. Okay, the socially optimal, this what would I say? Socially optimal quantity that is bought and sold, the socially optimal market clearing quantity would be 80 in this case. So in the actual market, what's bought and sold is 100, but if we took account of the externality, 80 would be what would be bought and sold. So question C, if suppliers do not take account of the social costs, is the market clearing quantity too large or too small? This is the market clearing quantity, 100. It's too large. Okay? We see what socially optimal is 80, should be 20 less. Okay. D. Okay. What if the government charged gas stations a tax of $1 per gallon? What would happen to the supply curve? Okay. So now, if every gas station, if I'm a gas station owner, and the way we build this supply curve, we say to sell 80 gallons, what price do you need to get? Well, before this tax, I would say 250. It's actually at every quantity. Would say what would you need to be paid to sell that quantity, and every answer would be 250. But if there's a tax, I've got to pay an extra dollar to the government. So if you ask me, what price would you need to sell 80 gallons of gasoline, or I would say, well, it's 250 my cost plus this dollar tax, so 350. Okay, so what that means is my supply, what the amount, the price I need is going to be a dollar above the former supply curve. So the new supply curve is just this line that's a flat line at 350. Okay, what would happen? And so the answer, what would happen to the supply curve? It shifts up by a dollar. Okay. What is the new market clearing quantity after the tax? Well, the answer, if this is the new supply curve, here's the demand curve. The market clearing quantity occurs where the supply curve meets the demand curve. Draw a dotted line down. The answer is 80. Okay, so the answer to E is 80. Okay, so notice that we get the socially optimal amount. Okay, if we do the tax. And this is common. This is one of the classic problems. If you have an externality and you know the social cost of that externality, if the government will just charge a tax equal to that social cost, you'll get the socially optimal amount. You'll, in a sense, what happens is because of the tax, the suppliers internalize that externality, and then you get efficiency, the socially optimal amount. Okay, and that's very common. Okay, whenever you have a negative externality, if you know the cost of that negative externality, if the government just charges a tax equal to that negative externality, everything will be fine. That's one way to solve that problem. Okay, and this is a classic problem. It's not in the book. There's a good chance something like this could show up on the exam. So this is one thing that I think that the book is a little negligent. It should have an extra section, something explaining something like this. It doesn't have that, but I've explained to you through this extra part of through this video. Okay, so this is part D. I'm on N, session 15 here. So see you in session 16 in a few days.